All right, this is the Chapter 11 Algebra Review. We did some of these in class, but I wanted to get to some of the others in case you had trouble. I'm going to start at number 15, okay? And we have the equation on 15, y minus 4 equal negative 1/3 x plus 6, okay? And it says, what's the slope? Well, if you remember, this equation is in the point-slope form. And the point-slope form is y minus y1 equal m times x minus x1. Okay, so the slope is just this number right here in front of the parentheses. So the answer to 15 is that the slope is negative 1/3. Okay, they're just going to ask us a lot of questions about this same equation. So 16 says, what is the x-coordinate on the point whose y-coordinate is 4? Okay, now let's think about this. If I have a point, the x comes first, the y comes second. They're telling me the y-coordinate is 4. Well, I could go up here and plug in that, but I want you to notice something. If I were to look at this equation, I'm going to kind of use some colors here to help me. Here are the y's, right? I'm not crossing them out. I'm just kind of highlighting them. I just can't highlight on this app. Here's the subtraction sign. Y already is 4 in this equation. This is 4 plugged in. It just doesn't look like 4 because the subtraction sign makes it look like negative 4 maybe to you. But the formula has subtraction signs. Now, since the y is sitting there and this is in point-slope form, okay, that means that that point is plugged in the equation and I can just get it out of the equation. I don't have to go do any algebra here if I know that that's how this thing is arranged. If you remember, you plug in an x1 and you plug in a y1. Well, here, so you might look over there and think that the answer is 6, but it's not. It's negative 6. Let me show you why. Here, let me pick a different kind of highlighting color. So remember, I'm not crossing anything out. I'm pretending I'm highlighting. There's the x's, right? Now, I don't have a the formula has a subtraction sign here. And I don't have that above. I have a plus. So what I'm going to do is rewrite x plus 6, this part right here, as x minus negative 6. I'm going to put two negatives to make a positive. Now here are my x's, here are my subtraction signs. What x1 did I plug in? I plugged in negative 6. So just remember, that's a little confusing because the subtraction signs change the sign on things. So the answer to that is the x is negative 6 here, because this actually was the point they plugged in and they were hoping you would notice it. If you didn't notice it, you could have plugged in 4 for y and solved, but you would have had an equation to solve, which is not a big deal, but, you know, if you don't have to do it, you kind of want to work smart, don't you? Okay, sketch a graph of the line. Okay, I'm just going to do a small little graph here. So, you know, in y equal mx plus b slope-intercept form, we always start with the number on the end, which is the y-intercept. Here, we don't start at the y-intercept because we don't know it. But we do know a point to start with, and it's this point right here, this negative 6, 4. It's my starting point here because I don't care where I start as long as I get a point on the line and then can count the rise over run from it. So if I start at negative 6, 4, that would be 1, 2, 3, 4, 5, 6. Oh, of course, it's going to be where I wrote already, right? That's just the way it always works. It would be about right here, so I'm going to put it, see that dot, it's over the 17 there. That's where that point would be. Now, if I'm going to have a slope of negative 1/3, and that was what we had up here for 15, remember that is rise over run, and I just happened to write my negative on top with the 1. I could have accidentally put it on 3 even. It doesn't really matter where it is as long as I just put it on 1 and count. So if I say rise negative 1, that would be go down 1, and then run positive 3 would mean go right 3, so 1, 2, 3. I could go down 1 over 3 again if I want to get more points, but I only need 2 points. It's nice to have more just to make your graph more accurate. Basically, that's what your graph's going to look like there. Now I'm going to go to the next, I'm going to take this to the next page just because it's full. Okay, 18 tells me to transform the equation into slope-intercept form. Well, slope-intercept form, I already wrote point-slope form because that's what form our equation's in. Slope-intercept form is that y equal mx plus b So if you remember, how do we put it in that form? We basically just solve for y. If they just told us solve for y and simplify everything, that's the same thing as slope-intercept form. Okay, so let's see. One thing I'm going to do with this equation is I notice that I want to really simplify both sides before I start moving things around, just because people make a lot of accident mistakes, that they didn't mean to make if they don't do that first. So let's look at the right hand. Let me just write the left hand side down and leave it the way it is. Y minus 4. But on the right-hand side, I'm going to distribute. So I'm going back up to this equation. I'm saying negative 1/3 times x. If I multiply stuff, don't I just smush it together, right? And then negative 1/3 times plus 6. A negative times positive is a negative. I'm just going to write that as a subtraction sign. And a third times 6 would be 6 over 3, and that would reduce to 2. Okay, now I'm not solved for y yet, but this makes it easier for me to do it. If I want to leave the y there, let me get rid of a minus 4 by doing the opposite, a plus 4. We always do the opposite, don't we, when we solve? Okay, and so y is going to be negative 1/3 x, and negative 2 plus 4 is a plus 2. Okay, so this is what that same equation would look like if I solved it and put it in slope-intercept form. Notice it's easy to see the slope on both of these equations. Here it is here, sitting out front of the x over here, and it's in front of the x here. So that's one thing that the equations have in common. The thing they don't have in common is in slope-intercept form. I now know that 2 is my y-intercept. And as a matter of fact, that's what they're going to ask me, part of what they're going to ask me on 19. When I solve for y, it's easy to get the y-intercept because it's the number on the end. Remember, this is a y value because it is the y-intercept, so it's a y value. And if you think about what is a y-intercept, it sits on the y-axis. So for instance, this would be like 2 on the y-axis. So your x would be 0. As a matter of fact, there's an easy way to remember that. If you have a y-intercept or an x-intercept, it's easy to remember which value is 0 because the opposite value is always 0. For instance, in a y-intercept, the x is 0. In the x-intercept, the y is 0. Okay, so it's always the opposite thing. That's how I always kind of kept track of it when I was trying to just quickly get it without having to draw a little graph and think about it. Okay, so how am I going to find the x-intercept? Well, if I know that y is 0, what I could do is this. I'm going to work from this form right here just because it's a little more simple than the point-slope form. If I know that y is 0, I could just plug it in to find the x-intercept. So I'm trying to find my x-intercept. I'm going to plug in y equals 0. Should say plug in y equals 0. Okay, so now I just have to solve for x, and I'll find my x-intercept. If I subtract 2 from each side, I would have negative 2 is negative 1/3 x, and if I want to get rid of the negative 1/3 with the x, I could multiply by negative 3 over 1. That would cancel out the negative 1/3, and I would get x equal negative 3 times negative 2 is 6. X equals 6. Okay, now you got to be careful about this. It looks, you might make a wrong assumption here that 6 is this 6 up here, and it's not. Just be real careful. It's not. It just happened to be this time, so just don't over-assume here. Okay, so now we're going to go y minus 4 equal negative 1/3 x plus 6, and I already found the x-intercept. The slope-intercept form of the equation, and it was this. And the reason that I'm writing that is because number 20 asked me to find the line in the form ax plus by equals c. All right, let's label these for a minute because these are your three major forms of an equation. This one is the point-slope form. Okay, the next one is the slope-intercept form. Notice that in these names, they're telling you what information you get that you could plug in to write an equation, or maybe what equation you could get out of it when you see it written down. You can go, okay, I can get on the slope-intercept, I can get the slope and the y-intercept. Now this last one, this is actually called standard form. And in standard form, here are the things you got to do. I'm going to list them underneath it. You have to get x's and y's on one side. Sorry, x's and y's on one side. My hand can't keep up with my mouth here. you have to clear all fractions, because it's like considered impolite to have something that's a fraction in standard form. And then you have to make sure your x term is positive. That's just considered, all of this is considered polite communication in math. There's like a protocol, if you would. It's not that it's a wrong equation if you don't do these things, but it's considered polite and correct to do it this way. I'm going to start with this one just because it's easier to move some stuff over, okay? Now, if I start, I'm going to do the problem now. This is actually problem number 20. I was just kind of talking about what we already had and what they want us to get. Now, if I start with that equation, the reason I picked it with the slope-intercept form is just because I already had an x term and a y term, and I know I want to move those to one side. And all my constant terms, they go on the other side, okay? So that's kind of implied in get x's and y's on one side. All right, so I know I got to have a positive x, and right now my x is negative. So if I were trying to decide which side to move this to, in order to make my x positive, I could just move it to the other side like this. I could just add it to the side, and it would turn positive. Okay, so that gives me 1/3 x. We always put the x term first. Then we put the y term. So 1/3 x plus y is equal to 0 plus 2 is 2. Now, I'm almost there. I just have a fraction, and that's considered impolite or not proper, okay? So what I'm going to do, if I multiply everything by 3, I could get rid of that fraction. So that's what I'm going to do. You just find the denominator, and if there's more than one denominator, maybe you've got some different denominators going on, you pick the least common multiple, which is the smallest number that all those things would divide into. Here we have 3 times a 1/3 x would just give me x. 3 times y would give me 3y. Got to do it to every single term. 3 times 2 is 6. So my equation would be x plus 3y is 6. And that completes the work on that one.